Thank you for all being here. I know the weather is really nice here, so yeah, thank you for all taking your time out to spend it listening to me. A little bit about myself. So Jamie Coleman. I'm a developer advocate at Sonatype, so I specialize on repositories, dependency management, dependency security, all kinds of stuff like that. Past experience, I used to work on mainframes actually for a year and a half, couple of years, which was a bit strange coming out of university to jump on, essentially terminals, which were green screens into mainframes, but it was a good learning curve. And then I went into the Java space, so worked on WebSphere, WebSphere Liberty, Open Liberty, OpenJ9, which I've forgotten what it's called now. IBM's rebranded it as something else, and that's the release. But so yeah, worked at IBM for a while, and then decided that I kind of had enough of talking about runtimes and things like that. So I thought security would be not so much fun, but a learning curve and a new opportunity. So I've been at Sonatype just over 6 months now. All right, let's get started. So Sonatype, if you haven't heard of us before, you will do now by the end of this presentation. So Sonatype, we're not just the Maven people. So like Anthony mentioned, Sonatype run Maven Central. We have done for a very, very long time, over 10 years. And Maven Central is just one of those things. It's just there, right? We all use it all the time. I was discussing with Anthony before you all joined about the cost of this because we're running this on, say, AWS, and you can imagine how many things are uploaded and pulled down, how many searches occur every day. So, and it's just something Sonatype have just done to support the Java community, really. A bit of history about Sonatype. So Sonatype kind of started, the founder of Sonatype and my boss, Brian Fox, he was one of the original contributors to Maven. And basically how he started out was when Maven became the build tool it is, he was going around to enterprises around the world and teaching them essentially how to use the build tool Maven because it was a new thing. And he was using that money to basically fund the electricity and the internet to run a computer which was under his desk, which was essentially powering Maven Central for, I think, a couple of years. And then obviously it got bigger and bigger. So then we had to look at a different option and it ended up in the cloud. But what you can see on the screen here is a new take on Maven Central. Maven Central has been kind of left the same way for a very long time. So Sonatype's trying to make it a bit more user-friendly, a bit nicer to look at, and add some extra functionality and security features into it. So if you do hit Maven Central today, you may be redirected here. Now you can go back to the old Maven Central, that's not a problem. But what we're doing is trying to gather as much feedback around the new Maven Central as possible, what you like about it, what you don't. The Maven Central team is quite small, so do bear in mind if there is burning desires to have a piece of functionality put in, the team behind it will try their best to get it put in, but of course there's always a backlog of stuff, and maintaining something that's been around for 12 years does take a team of people to do. So Sonatype, what do we do? Of course, we don't just run Maven Central. Most of you may have heard of, say, Nexus repository, which is essentially a repository for storing dependencies in. And Sonatype have other solutions as well. So Nexus Firewall is Nexus Firewall is quite amazing. I won't talk about it too much here because it's not an open source or a free thing, but what Nexus Firewall will do is basically stop dependencies going into your toolchain, into your repository. If it doesn't know about that dependency, our security team is always on hand. So if it's never seen it before, that goes off to our security team. Some AI happens. If the AI is not sure, then security researchers will then have a look at it. And within about 15 minutes, your organization will kind of get a result of whether that is a bad or a good dependency. And there's lots of other different things, and I'll talk about a couple of the free and the open source stuff kind of later in this presentation. I'm going to keep you too long because I know the weather's nice outside, but what we're going to talk about today, a little bit why open source is amazing, some of the problems we have in supply chain, what is software composition analysis if you don't know what that is, and possibly a little demo there. Then we're going to talk about why security in open source matters, a little bit about the legislation coming that is going to force us to talk about these things more often. Then I'm going to talk about our SBOMs as a solution here, about security posture and different ways and different organizations you can talk to improve your security posture. And then I'm going to talk a little bit about raw materials, which is kind of the term that has annoyed me into creating this talk here. Then a little tiny bit at the end about static analysis tools, then a summary, and then some links to some of the research I have here. I'm just going to check to make sure there's nothing in the chat. Yeah, so if you do have any questions, this is an open session, nice relaxed thing. So if you do have any questions, feel free to come off mute and ask me them, put them in the chat or save them till the end of the talk, and I'll do my best to answer them. So why did I create this talk? So like I mentioned, I was in conversations. Do I mention the conference? The conference was EclipseCon, big Java conference in Germany. And I was around some roundtables with security experts from very, very, very big corporations that are responsible for the backbone of many things we do today. And we were talking about open source and the supply chain problems we're having and how hackers are getting into open source these days. And they basically told me of a concept called raw materials. And a raw material, I won't explain too much about it, but it essentially allows you to bypass policy. And this kind of just, I was like, what you're bypassing security policies just to get this stuff in without fixing the bugs or doing the right checks, etc. And I wanted to know more about this. So that's why I created this talk. And I'll talk a little bit more about it afterwards. The only problem with creating this talk is these are concepts that people don't like talking about on the internet because they're very bad practices. So finding extra information about this other than talking to these people is quite difficult. I have provided some links at the end to some of the stuff I'm talking about today. But like I said, this is not a practice that many corporations would ever want to share that they're doing, but they are doing it, which is why I created the talk. So we all know open source is amazing. It makes our lives a lot easier. It's been around for quite a long time. I think 1953 was one of the first examples of open source. I can't remember the medium they were using to ship this stuff to their customers, but that was kind of the beginning. And open source, I think, since Linux became a thing and the Linux kernel became a thing, that's when open source really started to get traction. When Oracle open sourced the JDK, that then propelled open source projects and contributions even more. And then I think what really made open source available to the masses and accessible was GitHub. GitHub really changed the game in terms of how we, where we store our code, how we communicate with each other when we're developing code, all those kind of things. And then, of course, Android, it's open source, and it's one of the biggest. It is the biggest mobile operating system in the world. So I don't need to preach to you all about the benefits of open source. Being able to study, copy, modify, redistribute. I know different licenses have slightly different terms of what you can do with open source, but generally these are kind of the core concepts. You can fix bugs a lot easier. I mean, I could have a problem with I could find a bug in the application. I could write an issue about it, and then I could go to sleep and say someone in America, or more Westernly, will then wake up. They could see that and actually have that bug fixed by the time I wake up in the morning. So having people around the world working on an open source project really is quite amazing. And it's free as well, of course, if you want support, etc., or someone to shout out, it's there. But collaboration just makes life just easier. Sharing is better. And here's a stat from the Sonatype software supply chain report, which we put out every year. But around 90% of the contents of the code in our applications is now open source dependencies, which is great. That's amazing, because imagine if we had to write all these dependencies, all these classes that we're importing from scratch. It would make our jobs a lot longer. But there are problems with this, and bad people and bad actors are taking advantage of those problems. So what are the problems we're having when we're switching to use more and more of this open source code? Well, here's a small equation I like to think about. So the average Java project will have around 150 dependencies. And if you imagine per year, there's about 10 releases for each of those dependencies. That's 1,500 updates to consider per year. And that's for a standard an average Java project. So you can imagine the really big Java projects, how this gets a bit confusing. And then it gets even more confusing because, say, for example, in this is a snapshot from Bomb Doctor, but I'm in, say, importing the Spring Boot starter dependency, which might look great, but as you can see, that dependency then depends on other dependencies, and then those dependencies depend on other dependencies. So you end up getting this web and this mismatch of all these different dependencies. And Spring Boot's quite a secure, quite a well-maintained and quite a secure project. But as you can see, if I look down there, one of those dependencies is not in a good state, whether it's a security vulnerability or it's got a bug in it, etc. So having kind of tools that allow you to look through your dependencies and your transistors dependency is quite important. And it's not just that they can they're attacking our supply chains in lots of different places now. They could be doing it upstream in the actual open source repos. They could do it downstream. They could even introduce malicious, because a lot of the tools we're using now are also open source. So they can actually introduce malicious code into the tools we're using in our supply chain. So there is unlimited, there's so many different places hackers and bad actors can actually get bad stuff into our applications these days. So you've got to be careful. There are different dependency exploration techniques. Dependency confusion is one. So dependency confusion basically attempts to get a different version, so they'll add latest to it that people will automatically pull down, because a lot of people do just pull latest. Don't do that, or try not to do that where possible. Typo squatting, so it's basically a very similar name. So for example, they could do Spring Starter, and they could change, say, the R to an extra E, or change one character, and that would then allow essentially people by mistake might accidentally make that spelling mistake in their builds and pull that down, and boom, the malicious code is in their application. They're building it. Next thing you know, the bad actors have access to our systems. And of course, there's more high-level stuff. So open source repo attacks. This is where, for example, a bad actor could be pretending to be part of an open source project. He's there, adding fixes to the project. He's won over the community in the project for, say, a month, 3 months, 6 months, a year. But he is a bad actor, and he is still intending to do bad stuff. So what he might do is win the trust of everybody, add in some pull requests to fix some stuff, and the community, they trust this person, and next thing you know, he's got a bug or he's got a vulnerability into that very popular open source project. We're all going to pull it down, and next thing you know, we're all vulnerable. So there's lots of different ways to do it, and like I mentioned before, build tool attacks. Build tools being open source these days, people can do the same kind of social engineering to get vulnerabilities into our open source tools that we're using and get that stuff into our application. So that's not good either. And then just to make life even harder, dependencies, now we have lots of them. So before, more with a monolithic application or one application or maybe a couple of application or a distributed monolith, they're a lot bigger, a lot chunkier. So everything's kind of we can manage the dependencies a bit easier, but now we've got to consider Kubernetes, we've got to consider microservices. It's a lot more to consider. And I think Java with microservices has a bit of an overhead, because obviously you have to have a JVM in every container. You might have to have a runtime in that container, etc. And all of these things open up more avenues for hackers and bad actors to get into applications. Software composition. Oh, I accidentally went too far. Oh, no, it's all good. Okay, software composition analysis. So if you don't know what this is, there is some great articles on Fujay, which me and a couple of people, Steve Paul from my team and Dan from my team, have produced to kind of summarize what software composition analysis is. And we've used a cake as an analogy here, because most people like cake. They look nice, and they're quite easy to relate to. There's a link at the bottom there if you wanted to check out the article, etc. But
sorry, Jamie,
yeah,
before you go in, we have a question here.
Oh, yeah, sorry, I didn't see that.
I'll just read it for you. So
yeah,
you're arguing, so one of the original promises of open source was it's more secure because we all can inspect the code. Right?
Yeah.
So in a way, are you arguing that actually open source is making it easier for security vulnerabilities to be introduced?
Good question. I'm not saying open source is allowing that. Well, it kind of is. So yes, traditionally, open source is more secure in some ways because, like you said, there's lots of different eyes around it. And the traditional ways hackers and bad actors get into our applications is changing. They know trying to brute force into stuff now is getting more difficult with the complexities of firewalls and how we're managing things. So now they're using more social engineering techniques. At the beginning, so this is why, actually, I should have mentioned this at the beginning. This was why Sonatype was created, because Brian, he basically was running Maven Central. He was teaching all these big enterprises around the world about how amazing open source is and how amazing Maven, how easy it is to use Maven. But then he started noticing that hackers and bad actors were changing the way they attack people. They were using more social engineering techniques. They were trying to get into our supply chains rather than brute force our production application straight away. So it is open source is if you're not using any open source and you're writing essentially all of it from scratch, you are going to be much more secure than you are if you're pulling down open source dependencies. Now, what you can do, there is lots of methods and lots of ways you can minimize the risk of pulling in, say, a open source dependency which has vulnerable code that is produced by a bad actor, which is kind of what I'm going to talk about slowly as I go through this presentation. But yes, open source, if you wrote this stuff yourself, you're much likely to be secure than you are, as long as you've got obviously good engineers, than you are if you're pulling in free open source code that's on the net. But no realistic scenario will that happen where a company is going to, and there's a few scenarios like medical devices, and I'll talk a little bit about that later, but most companies will, will take the risk, but they will also manage the risk by using tools and functionality in different products and different solutions to limit that. Hopefully that answered your question. And I mean, so you take, for example, Log4j. Log4j, that vulnerability came out. Yeah, a lot of people got hacked and a lot of money. It cost a lot of people a lot of money. But being an open source project and having people, so many eyes on it, that fix, well, second time round, but that fix and that vulnerability was repaired quite quickly. So yes and no. It just kind of, that stupid answer I'm going to give you now, it depends. But hopefully that answered your question. So back to software composition analysis. Yeah, essentially I like to look at it as cake. So we're looking at this cake here. What can I see? Well, I know I can see the sponge in there. I can see there's some icing or cream and some icing possibly on the top and some cream in the middle. But I can't tell exactly what ingredients went into that sponge. I can make a guess, but I can't tell exactly by looking at the cake what ingredients have gone in. And that's kind of what you do with software composition analysis. So I can look at my build tool, and I can look at, not my build tool, my Maven pump file, for example, and I can see all the declared dependencies I've got. So I know I'm pulling in those dependencies, and that's like just looking at a piece of cake. I can see them, they're there, I know what they are. But what do those dependencies then contain? Ooh, let's focus, there we go. So what do those dependencies contain? Well, that's where things like SCA tools really dive into the actual, the bill of materials and into your project. So then it can tell you, in the cake analogy, for example, that sponge will have flour in, it might have egg in, it have butter, things like that, which you wouldn't get by just looking at, say, your Maven POM file. So a basic tool, like I mentioned, will list your declared dependencies, and it'll give you some basic information about them, say what version it is, maybe if it's okay, it might tell you there's a version update available. But more advanced tools will provide stuff like I showed you before, the dependencies of those dependencies, which we call transitive dependencies. It'll give you stuff like vulnerability and license data, and it can pull that stuff from, for example, if you've used OSS index by Sonatype, that stores a lot of vulnerability data which you can access. It can do stuff like project scoring. So there's a project around called scorecards, which a lot of projects are taking advantage of, which essentially gives your project a kind of security rating. And that can take in things like, for example, your security posture. What do you do? Do you have secure branches? Things like that, just to kind of assess the risk or the possibility that a vulnerability might be in a project. It can give you stuff like visualizations, like I mentioned before, license data, and some of them can produce things like SBOMs, software bill of materials. So I'm going to show you a very quick demo of Bomb Doctor. Hopefully everything all works here. So this is Bomb Doctor. This is a free tool by Sonatype. And what it does is it really tries to help you kind of visualize your dependencies. Let's have a look. So I used the Spring Boot one earlier. Yeah, why not? Let's have a look at Spring again. So it tries to gamify a little bit and turn kind of something that you might consider a bit boring to do, something that you don't really want to be having to manage, etc., and turn it into a bit more of a fun activity. And it helps you kind of visualize, you know, the state of your application. It'll give you a whole project a score out of 500, and it can really dive down into lots of different things. So as you can see, for some of these, there are updates available. I can click on them and it'll say this is the best update to, this might be the best version to update to, in regards to how many vulnerabilities might be associated with that, how many bugs might be associated with that. You can go down, you can break down into the score if you really want to find more information about it. Now, what Bomb Doctor won't do is it won't allow you to update something that has a breaking change. It will tell you there's a breaking change in that update, that dependency update, and then you will have to go and make a decision of whether you want to make that update. But it can give you nice reports about the different components in there. You can see what vulnerabilities are in there, security vulnerabilities, etc., how important they are. So like you can see this one, this is a particularly bad dependency here. So this is kind of the SBOM reports. You can preview a PDF and you can download all this stuff into a PDF to see if it's to make it useful for you. So I'm going to leave that there for now. I'm going to go back to my presentation. That is my very, very, very brief introduction to Bomb Doctor. So yeah, sure.
From me this time. What's the input like? Is it an SPDX tornado file? Is it like
it's a Cyclone DX, I believe.
Cyclone DX
I'm pretty sure. Hang on, let me just check. It's correct. Yes, Cyclone DX. If you are using a different file format, there are tools to convert between them. It just depends what you're using. I think we just picked Cyclone DX at the time because it was the most popular one. But I know GitHub have now done something that you can, I think you can generate SBOMs through GitHub, and they've picked a different format. You know, it's the way of the world. Someone always picks a different format. But there are tools that are available to convert between the two. But yeah, to answer your question, Cyclone DX.
Thank you.
No worries. Okay. So why security in open source matters. So now I'm going to be the doom and gloom person. I'm going to shock you with some crazy stats about open source security, hopefully into scaring you into considering some of the things I'm talking about a little bit. So some crazy facts here. Did a bit of research, and in 2016, cybercrime surpassed the drug trade. At that point, it was making $450 billion a year, 14,000 US dollars a second, and equivalent to about 50 of the world's largest nuclear aircraft carriers, or currently the largest nuclear aircraft carriers. Now, what about in 2022? Do you reckon that's got larger? Yep, unfortunately, it has. So I only have data from 2022, but in 2022, cybercrime actually hit $6 trillion US a year. That's 200,000 US dollars a second, and that's equivalent to 620 of these humongous Nimitz class aircraft carriers. So cybercrime is making a lot of money these days. And if I compared that to a country's GDP, we are looking at possibly on the third largest countries in the world in terms of gross domestic profit. And that's just from cybercrime. And I think if people like Pablo Escobar were around these days, he probably wouldn't be in the drug trade anymore. He'd probably be using a laptop to make his money, because there's a lot of money in cybercrime, and there is a lot of ways people are taking advantage of our negligence and our trust of each other for using things like open source. Another problem that is also happening is the 0-day window. So this is kind of the window from when a vulnerability is announced until essentially you can get it fixed or you get hacked. And that is now getting down to a very small amount of days. For example, when the Log4j thing came out, it was hours before big corporations started getting hacked around the world. So now we can't rely on, okay, we can fix this vulnerability. Oh, we've got a critical vulnerability. Oh, maybe we can get it into next quarter, or maybe we can get it into the next sprint. That window is now shrinking dramatically. And if it's one of the big open source projects, you probably want to get it fixed that day or even sooner. What devices are allowed to contain open source code? Pretty much everything. Even healthcare devices. There are a few things that might be, well, they have to abide by a certain standard, but generally everything is using open source code. Aircraft, aeroplanes, trains, everything. So we do need to be very careful, especially if we're working in an industry where we're providing software that basically keeps people alive. That's when we've really got to consider making sure the dependencies we're using are not containing loads of vulnerabilities. Now, legislation. Now, as much as, we as developers, we try our best with security, but realistically, it's kind of being forced upon us more and more. Well, that's not going away. That's unfortunately going to get even more so. So it makes sense to, rather than wait to be forced to have to do this stuff, to get ahead of it. Now, there's a lot of legislation coming around the world. In the essence of time, how long have we been? I'm not going to go through them in large amounts of detail. But the point here is, and Brian Fox, like I said, he's the founder and CTO of Sonatype and one of the original Maven guys. He's basically trying to say here is it's better to get ahead of this, because, for example, in manufacturing, you wouldn't let a faulty ship go into the sea. So why would you let faulty stuff go into your software? So the US, this was a big announcement. I think it was about 2 or 3 weeks ago. They're basically now, the main things to take away from this is software providers and data owners are now going to be held responsible for security. A lot of the time is they could pretend, or not pretend, they could say, well, the security vulnerability came from an open source project, so we're not responsible for that. That's changing, I think, over the next 2 or 3 years. So if, for example, you sold some software to the US government, and they got hacked, you're the ones that are going to get sued by the government and taken to court. So they're trying to put processes and practices around basically how we develop software. And this is not just the US, the EU. We at Sonatype are actually working with, Brian Fox was going into the White House to help them build their national cybersecurity policy. We're doing the same thing with the EU. Similar kind of requirements for the EU, being responsible for your code, making sure critical stuff is managed in the right way. And if you do find a vulnerability, how are you going to communicate to the users of your software that that's there, and what is your kind of action plan in regards to fixing that vulnerability? So all these kind of things are being required of us. And the UK is no different. We're working a little bit with the UK National Cyber Security Agency, I think it's called. The main difference here from the UK's point of view was, which is something I quite liked, was ban default passwords. It's kind of a no-brainer, but that's kind of, when you ship a bit of software and it's got a default password in, that will be made essentially illegal going forward. But this is something, all these bills, well, the EU and the UK one are still in discussions around a lot of things. The EU one's a bit more mature, but the US legislation on this is pretty much defined and will become active in the next few years. So you probably heard a lot about SBOMs. Everyone's talking about software bills of materials these days. SBOMs are all right. They're great, but on their own, they're pretty much useless. If you generate an SBOM and don't do anything with it, then it's a complete waste of processing power to generate that SBOM. So what it is, the real power is what you're doing with that. So there's lots of easy ways to generate SBOMs. You can say you use the Cyclone DX Maven plugin. Kubernetes has a way to do it. Microsoft has an SBOM tool, like I mentioned earlier. GitHub has now put that functionality, that functionality into GitHub itself, which is awesome. And a SIFT and Sonatype Lift, which I'll talk about a little bit later. And the problem is, even our SBOMs are safe. So if our SBOMs gets hacked, hackers can, change our software bill of materials to make it look like the dependencies we're using don't have vulnerabilities in. So there's a lot of work going on around SBOMs on how to secure them as well. So yeah, all great fun. Security posture. So this is just this has changed quite a lot lately. So I think about 3 or 4 months ago, only 2 of these organizations existed. And as you can see, there's a lot of them around now, 2 or 3, I think, or maybe 4. But there's a lot of them around now that are really considering how we create standards for managing open source security. Because no one wants to give up open source code. Open source code is amazing. We're always sharing it with each other and helping each other out. But we need to have some kind of processes and standards around consuming this stuff rather than just pulling stuff down from Maven Central every time we want it. This is kind of this is how Bomb Doctor and OSS Scorecard and other things, I think it's especially OSS Scorecard, looks at different projects. And as you can see, some of the biggest factors that will reduce your project score or make your score better would be simple things like code reviews, having branch protection, things like that. These, I mean, you know, some of us will think they're obvious things. Some of us might not do them and not think they're useful. But when there's projects out there, if you've got an open source project and you're not considering these things, just bear in mind there's lots of other companies that are rating your projects, and they will get rated poorly if you don't consider your security posture in terms of how you develop the projects. So just some notes there, just things to think about in regards to small steps you can take to improve the posture of security in your open source projects. Small things do make a difference, like I mentioned. So code reviews were the first one. Have binaries outside your project. Don't have dependencies pinned to a specific version. That's not good. Don't have them sat at latest either. Have kind of a process for how you update your dependencies as you go along. Don't stick on a specific version because it works for a long time, because eventually it might get vulnerabilities. Don't also pick latest because there might be vulnerabilities in the latest code that's being developed. And like I mentioned, protected or secured branches, which is like GitHub, to make sure no one else can, you know, push and pull and stuff to your branches. So kind of getting to the point here and towards the end of this conversation, what are raw materials? So raw materials are essentially, so imagine this is your normal software supply chain. And you have third-party software, such as open source code. You could pull that down from Maven Central, put it into your application. Yes, it's got the classes you want. You build your application, the build runs. Great. But as part of that, generally, when we're using dependencies from open source projects, we have a good idea of who's running that open source project, how active it is, what its security posture is. There's lots of different things we consider when we choose an open source project, or at least we should do. How often is new releases coming out? When there's a major vulnerability, how long does it take for them to fix? Now, the concept of raw materials are slightly different. Concepts of raw materials are, we don't know where this open source code has come from. Yeah, it might be a Maven Central, but we don't know anything about, for example, the author. We don't know about anything to do with how it's developed, its security posture, all these kind of things. How often, well, we might be able to look at how often a releases come out, but what companies are doing is basically if open source dependencies fall under this kind of banner of we don't know the origin, then they mark them down as raw materials. And that essentially bypasses things like policy control. So I might have a policy control that says, if the security posture of a certain open source project that this dependency is coming from is poor, don't allow it into my application. But if I can't find out that information and I mark my dependency as raw materials, it might bypass that policy control. And again, that goes back to the supplier hygiene thing on here. We just simply don't know if it's from an unknown source. And I was sitting around the table with, like I mentioned, with a lot of big organizations that run the backbone of telecommunications and this around Europe and around the world. And they were quite happy to be doing this because they did not want to have to go through the testing of that to make sure it was in the right state. They didn't want to have to fix bugs and vulnerabilities that might be there. So they were marking this stuff down as raw materials to get past that. And that was quite scary to know that they were doing that with confidence, just because essentially they're not the ones responsible if their customers get hacked. They can just say, well, we didn't build that code, so it's not our responsibility if it's got vulnerabilities in. And that is a really, really bad way of doing things. Now, that is all going to change because legislation is going to make these big corporations responsible for this stuff. But really, that was kind of why I wanted to create this talk, is to kind of bring that notion to people, to let them know that, you know, realistically, these things happen. And, you know, vulnerabilities or bugs can be the smallest of things. So this isn't a very high critical vulnerability, but that slight mistake there that equals will add a vulnerability and allow bad actors to possibly get into your application. So it's not even the open source community we need to worry about, it's also us. We also need to be careful that, you know, the code we're producing, because that code might work for us, but it might introduce the vulnerability that we don't want. And this is why a lot of the tools and things that are around nowadays are quite useful. So this is kind of where static analysis tools kind of come into play. They're quite cool. There's lots of companies doing them these days. So what they do is they kind of look through your application source code for, sorry, I lost focus again, for stuff like they enforce coding standards. So I'm not going to say good coding practices here, because different people have different opinions on the best practices or good coding standards. But what it could do is they've enforced the same coding practices throughout an organization. That way, you know, it's a lot easier to read the code later on, compared to you've got lots of different teams or lots of different developers coding in different styles. So, you know, the readability of that code could be difficult. It can help with, you know, insecure coding patterns. It can measure things like your test coverage, control flow, nesting. I mean, and they can even look at if your documentation is correct and the requirements documentation and all kinds of cool things like that. What time is it? Okay, so I will try give you a very quick demo of Lyft while we're here. All I'm going to do with Lyft actually is, do I want to give you hopefully you can all see my screen. Do I want to give you a painful project? I'm pretty sure test containers is a hell of a, of a big project. Let's go with something nice and small. Let's go microprofile config. So yeah, so this is an analysis I did of microprofile config. Like I mentioned, it can give you some advice on coding practices and things like that. It can also talk about the dependencies that it's got here. So this is where it might utilize some of the information from BOM Doctor. And we click on here and it'll give you more information about the CVE. CVEs are a way of kind of logging vulnerabilities that are known, etc. So I'm here for now. What I'm going to do is something really simple, just so we can all go and jump in the sun after this. Dependencies, I can click export cyclone DX, so it'll create that dependency for me. And then what I should be able to do is go to BOM Doctor, go to my downloads, and I think that is the one I need. So what BOM Doctor will do, it'll take your SBOM, so you can generate this for any one of your open source projects or anything like that. And then it'll load it in so you can have a visualization of some of the dependencies. Now, as you can see with this project, there are very limited solutions in terms of what updates we can do. It's not a badly scored project anyway, to be honest. I was going to load in test containers, but last time test containers just went poof and took over my whole screen because there's a lot of dependencies in there. It was quite a good thing to show because yeah, it talked about some of the things down the thing. Also, it looks like licenses might be one of the reasons that it's a bit restrictive. But yeah, so it gives you a nice overview and can give you insight into if a certain library or a certain dependency is vulnerable, or if it's a good fit for your application in terms of what version it's at, are there any later versions, and all those versions have breaking changes into my code. So that is my very, very quick demo of Lyft. I think I'm pretty much at the end now. So just to summarize, this might scare you a little bit as well. So remember Log4j last December has, you know, one of the biggest, or if not the biggest Java vulnerability ever. Well, I took this data, I think last week, and currently 29% of Log4j downloads from Maven Central are still that vulnerable version. So 29% of downloads of Log4j are still that vulnerable version, which we all cried about last year, all panicked. Yeah, 29% of people, well, not people, but I don't know, 29% are still that vulnerable download. And this kind of takes it home that their luck will run out one day. Maybe they've just gone unnoticed, etc. It's a good job the Maven data isn't public, so people can't figure out who these people are, but it's quite a scary thought, really. So like I want to point out here, your luck will possibly eventually run out. There's different things you can do to essentially, kind of make sure your dependency, you pick the right dependencies. So what's in your application, what dependencies you currently have there, assess those. Like I mentioned, don't stick on latest, but don't stick on a certain version number. Have a continuous update strategy. So I'm at version 3. Version 3.1 comes out next week. So hopefully by the end of the week after, we'll be at 3.1, providing there's no vulnerabilities announced, etc., things like that. Have constant security scanning, and have that, if you can, through the whole breadth of your supply chain, because like I mentioned, these vulnerabilities are now can be introduced at different stages. So if you say just scans at the beginning, and one of the tools you're using to build your application has a vulnerability in, you're not going to pick up that vulnerability if you're not doing any scans after you've used that build tool. So do think about how you scan things as you go through the life cycle, and have a remediation strategy. So if there is something that comes out that has a vulnerability, have a way of getting that vulnerability fixed, whether it's your team, whether it's using ability to downgrade to an old version, have a strategy in place for that. So one thing I should mention, so I've also noticed raw materials being called soup. So do check that out. Software of unknown something. I always forget. I generally use the raw materials reference, but there are some information on those links if you want to know a bit more about how this works. And like I said, it's not something many people and organizations talk about, so you will struggle to find this stuff on the internet. There's some history of the software supply chain hacker. That is a great interactive webpage. You just scroll down, it'll tell you about all the different supply chain hacks. The state of the software supply chain report is a good place to go. If you want to see the log4j data that I showed you earlier, you can go to that link there. And if you want to know more about the legislation coming out of the White House, we do have a blog on that. Do get in contact with us. We do love to talk to everyone, even if it's not about Sonatype technologies, about opportunities, about anything. Do send us a message on Twitter, LinkedIn, and we'll be more than happy to get back to you and have a conversation if you want to about any of our technologies or just about the industry and security and supply chain in general. Some cool stuff to check out here. There's a new Maven Central, like I mentioned at the beginning, so you can go check out that. We do really want your feedback. You may see a feedback thing pop up. Please do answer it if you do have the time. Otherwise, it's your fault if Maven Central goes in the wrong direction to what you hope. Bomb Doctor, like I said, that was a tool I showed you earlier, so do check that out. DevZone is a place at Sonatype where we blog and create articles around all this kind of stuff. Like I mentioned, we have a FOSS series that describes software composition analysis, SBOMs, and things like that in a bit more detail. So that's all on FOSS. And we also release something called Malware Monthly. Malware Monthly is where the security research team go look back through the previous month and look at the biggest hacks that's happened, the biggest vulnerabilities they found, etc., and list those into a kind of like a monthly newsletter to talk about how they were identified and things like that. And honestly, if you listen to some of the things, how the security research team works, it's quite amazing how they go through the process of figuring out if a dependency has vulnerabilities in, because trust me, hackers try every little thing possible to hide that code inside these dependencies. We've got a bit of a feedback form, so feel free to check that out if you I can put that link in the chat. But other than that, I think that's the end of my session. So do we have any questions? If not, I hope it was useful to you all. I think it's going to take about a week for the video of this to go online on the YouTube channel. But I think that's it from me. And if there's no one asking any questions, I will hand it back to Anthony.
Jamie, thank you very much. It was a
No worries.
wonderful presentation. I think
Thank
I'll
you.
have a question of my own, actually. You kind of
Sure.
went through it a little bit, and I'll try to make it brief because all of us want to have an ice cream or something like that. But I assume that you are like a typical Java shop, you know, when you have, I don't know, you have you're using Maven or Gradle, you have Spring Boot applications, you're deploying things using Kubernetes, maybe a sort of a CI/CD pipeline, Sonar Cube, but no vulnerability analysis, no scans, no SBOM, nothing. Now you are worried about like new legislation and all of those new vectors and surfaces of attack. When you start looking at it, you end up like on proprietary product X that does OWASP analysis and handles everything for you. But it's kind of hard to like get started. Like, what would be your advice if you want to get started fixing those sort of issues?
So my advice would be, first of all, just generate an SBOM and find some kind of free tools like Bomb Doctor, for example, to use that SBOM and just kind of have a look at the state of your current applications. And once you can start doing that, you can then once you start understanding what projects are more secure than others, what versions are better, etc., that can then inform you to make better decisions for your future projects. But how I would say about going about it now is just start by creating some SBOMs for your projects, throwing some free tools at them to see, hopefully your projects aren't going to be in too much of a scary state, but having a quick look. Once you've got to that point, whether you're scared or not scared of the state of your project, that's when I'd start thinking about creating a strategy of, you know, is it worth us upgrading this project? How are we going to do that? If we get off these vulnerable versions, will it break any of our code? And also you can manage vulnerabilities as well, because a open source project might have a vulnerability, but if you're not using that bit of code, it might not be such a worry for you. So also do check that the open source library you're using, if that's the only version available, then I would say go and have a look at, for example, am I using that functionality? And if not, then it's not a massive worry for my organization at this moment. But yeah, like I said, have a look online, find some free tools, generate some SBOMs for your project, throw the free tools at them, and then have a look at the state and then start doing that. But I think the first step that everyone can do is just generate the SBOMs, because once you've got the SBOMs there, you can then go and do something with them. Whether you do something with it today or in a week or in a month, you've got it there anyway. So, you can plan ahead then. Hopefully that answered your question a bit, Anthony. You've just reminded me that I need to write an article about how to get started with this stuff, basically. But yeah, future plans.
That was brilliant. Any other questions for Jamie? Feel free to unmute yourself and
do reach out to me on Twitter. My direct messages and everything are always open. I am traveling around a lot to lots of different conferences. So if you're going to any Java conferences, let me know, and hopefully we can meet up there and have a chat about any of this stuff if you
want. 1, 2, 3. Okay, so thank you, Jamie. Like a huge round of applause.
No problem. Thanks for having me.
Hope to host you again.
Take care, everybody. Enjoy the rest of the sun. You've got a few minutes left.
Thank you very much.
Take care, everybody. Bye.
Bye-bye.